Okay. So thank you. Welcome to week 9 of data arrays and aliasing. Has anybody worked with data arrays before, aliasing? Do you have kind of a concept of what those are? No, that's okay. Yeah, I can't think of an application where I think an electrician would run into this. It's definitely a programming. Most languages have this in some sort. So if you're not getting something, just ask questions. So we've been using data arrays aliasing from day one in the labs. So I'll show you how it's being used. It's one of the examples. But PLCs have a variety of methods to locate and retrieve information. So you've seen that with the SLICs, with those data tables, the integer, the N registers, and the F registers. And then we have tags for the PLC 5000. So one of the things with the N registers is things were logically in order. So that lent itself very well for being able to reference and do things in a sequential format, because you could build your F8 register and all your words would move sequentially. But when you do that in, is my screen's sharing, right? You can see this? I think so. Yeah, I see my sharing thing. So when you create tags in 5000, you don't really get that structure. You can create an individual integer, int, and all you really get are your 16 individual bools, or you would have access to it as a decimal. That's going to error out because you're limited to your decimal. So one of the tool to get around that for Logix 5000 and many other platforms is what's called a data array. So I'm going to delete. Oh, you got to edit tags to be able to delete while you're online. And we'll call this data array. And let's say we want these to be real numbers. So here we will then specify, I'm going to click this dot, and this will kind of help you see where this notation comes from. So we've selected our tag type here, and this says array dimension. So you can have multi-dimension arrays. They get kind of complex to wrap your head around, but we'll start with baby steps. So let's say you have 10 pieces of information that you want to store in one location. Oh, lose here. You can select this and type 10, hit OK. You'll see here, we've now created data array square brackets 10. So when we click off, well, now what we have here is we have data array and then 0 through 9, because we're a computer and we always start counting at 0. So now we've actually created 10 real tags under one tag, and all of these can be used separately. So this allows us to be able to build and use a data array sequentially. Does that make sense as to what this basic array function is? It's just kind of using one tag and having multiple pieces of data kind of hidden underneath it. Similar to that of using the individual bits of an integer, only these are all real values, and it doesn't have to be real. We can do any number of them. We can have arrayed dints, integers. You can even array timers if you want. So you can have a function block timer, a long integer, any of these. Even here's one, there's a message. Oh, you can't array messages. So PID control. So if you had a proportional integral derivative module and you needed to have multiples of them, you could array those. And the syntax for that is very much the same. Let's say you needed 6 for a very specific automation feature. Well, now you have 6 PIDs, and inside each individual one, you've got all of your subclass, your dot fields. So if you were to do this with, remember when we were doing user-defined data types, you can build arrays inside your data types as well. And then if you have a custom one, you can array that. And then when we get to multi-dimensional arrays, let's go edit properties. We could actually, I'm gonna show it on the other. We'll delete this one. We'll delete this one. And we'll go here. So we'll enter in 10 by 2. You could add a third dimension to it, but so then the notation here, click off, is we've got the 10 by 2, and what that does is, why can't I see that? We now have 2 points for every set. So the multi-dimensional arrays are good for storing information that's related to each other, like in a horizontal and vertical fashion. This is kind of a complex thing to imagine, but if you imagine this like a grid, and then you have X and Y, and then you add a Z axis to it, and the whole data table will then move further out. This is used for recipes, complex sequencing, when you want to move entire data sets or entire data stores in one go. Am I making sense? Multi-dimensional arrays aren't something that you'll come across very often. At least I haven't come across very often. I just wanted to point out what you're looking at here, because you can see with the multi-dimensional arrays, we have 10. So remember, we added the 10 real values, but we have 2 sets, 0 and 1. So it's 20 data points. Oh, Scott's here. All right, let me just quick update the attendance here. So when you see any tag that has the square brackets, the number in those brackets is the number of items in that specific array. So you can write array didn't, so you don't need to hit that button. You can just type in your brackets and then it will populate and create your didn't array of 50 items. So why would we want to do this? There's a number of reasons, but again, it's for keeping like data close to one another inside your tagging. As well, when you're using some special functions. So let's use, I think it's called average. Nope. AVG. Nope. Let's see. Compute math. Advanced math. Okay, come on. Don't tell me that the average is not built into this software. Sorry, guys. Huh. That's weird.
Try AV for the tag.
AV?
Yeah, just AV. No.
AVE. There we go. It's a perishable skill, programming. If you don't remember, again, that's why I'm always in the help files. Oh, here. Thank you. So we have an array, an average, and we have let's look at those. Man. So the array tag. So find the average of the values of this array. And then your dimension to vary. So which dimension to use in order of the dimensions is in the array. So you have to create an array. And then inside that array, it will look at all of the values in the array to then calculate the average of the values. Does that make sense? So you need to build an array for the average to be able to function. So if you wanted to pull, do we call it? Did it create an average by itself? Dimensions 2. Let's not guess. Let's not guess. Let's figure this out. Because I haven't used this average function in a while. destination. So we need to build a destination. So we'll call this the average is a real. The control structure for, so we're going to need, we'll call this control. And it's a data type control. So the length here and the position is going to be how long in the data array. Again. So the number of elements of the array to average and the offset into the specific array, which identifies the current element that the instruction is accessing. So we'll take here. So the dimension to vary. The dimension to vary. 0, 1, 2, 3. All right. So we have created, where's the tag that we created? A multi-dimension array. Let's just simplify things. And we'll say average real 10. We'll go back into our logic. Average length 10. Start at position 0. Does that work? No. Why doesn't that work? So then if we monitor average array, 1, 2, 3, 4. So this average instruction requires an array of data. It can't look at anything. It can't look at multiple different points. If you needed to average something, if you had 10 different calculations and you needed the average of those 10 different items, if you don't put them into an array, you'll actually have to do all of that math yourself. So you'll have to add up those 10 items and then divide that by 10. Where this average, we point it at the array. We look at the dimension. Again, remember the dimension being properties. We have a single dimension array instead of a multi-dimensional array. We have a destination, so that's where we're going to put this data. This particular average has its own control. So this average controller, it's its own data type. And then we indicate the length, which we are going to average. So if this array were 200 long, but we only wanted to average the first 10, we could change, we would enter that in here. Or if we only wanted to average the first 5, we could. We can change that because we don't, we can pick, we know where the information is and we can move around. So the total length of it and the last position, which we're going to average, 4 being the 5th position because we're starting at 0. Does that make sense? So there's many instructions that use arrays. Lots of times, if you're going to build like a data collection system or a data historizing system, one of the things that you can do is you can actually use another type of addressing. So this is called arrayed addressing. We can use indirect addressing. So you can use arrays with something called indirect addressing. So this was more prevalent in SLICs and 505s, where you had a lot of restrictions on memory. You don't see a lot of indirect addressing being used these days because there's far more memory available in the processors. But I'm going to show you here a pretty brief example of what indirect addressing would look like. So I'm going to use this dint array. So again, single dimension array of 50 items. So we're going to have an event, whatever that event is. Favorites. An event is CPU. We're going to branch. On this branch, we're going to move. Yep. I want you to go over here. So trigger. And then we're going to event counter. So every time the event happens, we're going to move. Let's see what we got. What do we have built in? Section. Whatever. Let's just call it time. So what is it not like? Oh, okay. So what we've got here, preset. All right. So in this instance, whenever this event triggers, we're going to move the time. In the real world, this would be associated with something else, whether it be a weight scale every time that somebody hits a button while their truck's on a weight scale, it prints the time, the date, and the weight of a vehicle into this data array. It counts. Well, now we can count in our data array. So array didn't, and we're at count 1. We have 1829. And we'll go back over to our code, and trigger is off. And 635, and we'll trigger again. And we increment up. So that's a pretty basic use of this. But as you can see here, we are indirectly addressing. So when the counter increments up, we'll go to 45. As it moves, it'll pick where we need to go. So this again was used a lot more when you had a lot of memory issues. So if you can imagine, if you have a lot of the same things happening in a slick, a lot of the same processes, whether they be pump drivers or the analog drivers. Everybody, you remember when I was talking about standardized code and add-on instructions? Well, in the slick world, or even the PLC 5s where everything's register based, you could use a counter and indirectly address a portion of your registers, so that on the first scan or the first count, it will do all of device 1, increment up, do all of device 2, so that you could approximate the data usage that is done using the fancy add-on instructions in a slick. Now, it was a huge burdensome thing to program, and troubleshooting was a nightmare, and everything had to be done perfectly. But it's what complex sequencing would look like on the older processors. So if you ever run into logic that looks very similar to this, so it would be like a F8 or an F8 colon square bracket timer accumulator or time of day to indicate that it's been indirectly addressed. You could also indirectly address this. Let's say if you had operators logging in to a machine, if you had an operator code, that code could be associated with a value in the computer, and then it would allow specific operators to change passwords or key commands or set points for very specific portions of code. Does that make sense? Does it not make sense to anyone? Anybody have any questions? Awesome. So one of the pitfalls of doing what you see here, can anybody guess, if you were paying attention, what might be about to happen? And if the array ends, so Vincent got that right. So right here, this dint array is only 50 items long. So one of the things you really need to pay attention if you're going to be using arrays and you're going to be writing into them is you need to write only into array data points that exist. So because this is 50 long, this will only go to 49. And as soon as we get past 49, the processor can't move into a data point that does not exist. This fault, it will shut down a system. I will admit I missed this because I had set something up for collecting 100 values, and I had this set at 100 instead of 99. And 2 or 3 weeks later, actually when I was on vacation and not able to assist, a process faulted and people were very angry with me. So if you're going to use data arrays, especially if you're going to move values into them, you need to make sure, double check that you're not going to move it into a position past the end of the array. Or, so what I tend to do myself now is, because you can't change the length of an array while you're online. So where did it go? Didn't array. You can't change that. But if you know you're gonna need 50 of them, like I said, we have tons of memory on these. Make this 75, make it 100. Don't go crazy. Don't make it like 5,000. I have seen that though. I have seen some pretty wild arrays. Let's see. I wonder if there's a limit. Let's go. Well, let's go 10,000. It took it. That is silly. Well, we're faulted, so let's clear the fault. It's not happy. Don't make an array 10,000 long on a VM. It is pissed. Oh man, I like breaking things. That's fantastic. Jeez. Sorry, the wind is loud. In December, I had a bunch of siding blown off the side of my house, and it's still not fixed because it's difficult to get at. So half of my house is a giant garbage bag tarp. So the wind is very loud blowing that bag around. Wow, it is. Yeah, I killed it. It's dead, guys. Yep. This is what happens when you try to be silly. Any questions while we're waiting for this to do its thing and try to remember how to use this? So we got two more types. Well, there's another type of addressing, but we've been using it directly. So it's direct addressing, and it's exactly what it sounds like. We have a tag and we will address it directly. So we're using, I created tag trigger, we're accessing it directly. If I create a counter here and I want to access the preset or the done, well, we access that directly. This is direct addressing. If we're going to look at local, so we want to look at some information on the local cards. We want to input the fire and output, and it's part of the local system. Again, we can directly address local digital input data 1. We've directly addressed that, but what you may or may not have noticed is they've set up some aliasing. So output 3037 is, whenever you type in the address here, is an alias set up to look at local 307. So aliasing is used somewhat frequently to kind of make it easier to find some information, or if you wanted to associate easier tags to remember. 037 is arguably easier to remember than local 30 data 7. It's easier to type in as well. You can alias almost anything, and one of the things that is a little annoying is you can only get at it through the edit tags, and you can only set them up new. So if you were to create a new, let's say, input fault, we will go to a local fault. So we can, and it's just, it's that easy. So if you have a tag, if you've got a data array, or if you've got a tag or a set of tags, and you want to have a different tag right to it, all you have to do is create the tag. So I've called this input fault, and then I've pointed it at local 2i fault. So that's our local card fault data. So now if we were to monitor, let me just make sure this thing is off. Local 2, yeah. All right, did that already. Oh, here's something. So right now you can see here that this is reading back as binary. You can change that, or sorry, yeah, it's binary. If you wanted that to be a decimal, you could change that. Decimal, and it'll read back differently. We change that to 45. Because I've inhibited the card, it's not trying to pull actual data from the card. But now you can see down here that these are linked. They are the same data point. Anything you do to one will happen to the other. So if this is input data coming from a card, you can read it down as, sorry, my ear started ringing. You can read it down here as a different input. I've seen this being used on a lot of vendor panels, where they will give a document for the data that you want. So they'll have inside their program a bunch of false information, and then they'll create an array for, or not an array, an alias for that, and they'll just have like SCADA tags or outbox tags, and they'll move their information into their internal bits. And then for messaging purposes, SCADA only reads the alias. So it doesn't matter what they move into them, they could populate them and they're called a specific thing. And they don't have to worry too much about moving data around. That's also done with data arrays. Sometimes if you need to pull information out of a vendor PLC or any other PLC, they will move the data that you need into a massive array of data, and they'll just say, let's say there's 5 PLCs that the information needs to be read from. They'll either make 5 different arrays, one for each PLC that's reading from it, or they'll make one huge array and say PLC 1 reads 0 through 10, PLC 2 reads, or sorry, 0 through 9, PLC 2 reads 10 through 19, et cetera, et cetera. That's a programming style, but it's an example I've seen aliases used, because sometimes things like local Ethernet 6.0:1:C is a pain in the ass to remember and read. Any questions on aliasing? You can't. So if you are online with a PLC and you add aliasing in and you mess up, you've got to delete that tag before anything references it, and you got to fix it. As soon as you start it doesn't even, edit tags. You cannot fix that online. And if you start referencing that tag in a whole bunch of code, and the aliasing is wrong, you will have to fix it offline and then download. There's no way around that. So it's a pitfall. Direct aliasing. All right, so one last kind of aliasing that is specific for Logix 5000 and Slicks. So only because some of you have said you work with Slicks. If you ever need PLCs, a Slick to read information from a Logix 5000 controller, because the Logix 5000 controllers use tag-based addressing and the Slicks use register-based addressing, they don't speak the same language. They both use the same CIP computer protocol, so they can transfer data from one another. But it's far easier for the 5000 to read from the slick. It can kind of do, you can tell it to point it at the integer registers. And as long as you create your data point on the slick, the 5000 as integers or reals, depending on what you're reading, it will do the math. It'll do the conversion. But to go the other way, you have to do this offline. So I'm gonna go offline. And what you need to do is under logic, map PLC slick tags. You have to over here create a file number. So any file number doesn't really matter. 191. And this is a tag that we have locally. Interesting. So I might have to create this tag. So we'll call this slick out. Okay, no, it won't be happy. Let's do this over here. Slick out integer. Ooh. Integer. Let's go 10. And then we'll go back up here. No. And then we'll download. So what this does is it builds a data table that the slick can read, and it will populate it only in a specific memory location. This emulator might not. Oh, it seems to have done it. So if we go edit tags, you don't see anything here. It doesn't show up anything special at all inside the tag. It doesn't show up like aliasing here. I could have added aliasing here if I wanted to, if I had thought about it, but I messed up. But if we go back up here into slick, we now have file 191 slick out. So this creates a data table where slick out is mapped to 191. So if you had a slick 505 or a micrologics, you could, and you were needed to get data out of this processor, you could then use a message instruction and read integer file 191 for, and because I put an array of 10, you could read 10 elements out of this. So you could put in here, let's say you had, oh, come on, open up, a level of 151. You had some on this one, you had a bunch of status inputs. So you had pump statuses. You could map those inside your logic in any way you wanted, because this slick out is just a normal tag. So we'll call this slick out. So we want array point 0 or 1. So again, because it's an integer, we have the slick out array dimension of, it's a single dimension, but we're going to the second point. So the second integer and then the first digital point. So when we go back here into our slick out, we can see that we've written into that. So that's pump run status or fault or whatever. You can, when you read these integers into the slick, they'll show up. And this is the only way to get the slick to read data out. If you wanted to do, you could do a float. So you could do a real value. You could also do, if you wanted, whatever you slick bool. There you go, bool. You can't go more than 255 because that is a limitation for a slick data tables. But let's say you had 100 bools for whatever reason and you wanted to read those, you could read bools. Maybe, sorry, you might not be able to read individual bools because the message block on the slick might not accept them. You can create them on this end. Most of the time I use integers. If you need to transfer multiple data points and some of them have decimal places, a common instead of having to do an integer and a floating point, so multiple data reads, you could actually include, let's say this was like 898.32, and then here oh, value's too big. Remember, it's an integer. So it's 123.42. And then right beneath it, have a scale. So you could take a move and then divide that by 100 coming out the other side. So that's a common practice, especially before integer reals were universally accepted inside controllers, is you would include right next to the data point a scaling factor, so you could divide by 10 or multiply by 10 to shift the decimal place around, or 1,000 depending on what you needed. I think here. No, yeah, so that is the end of my notes for the lecture. Let's see, we have a lab. Just want to make sure I've covered everything in the lab. Does everybody have access to the lab for week 9 through D2L? You're gonna, yep. And then there's a separate ACD file, which is what they've done is stripped out all the aliasing. So you'll notice, like I said, this file is one of the normal lab files that you've been working from, that had all the aliasing already put in. So part of the lab is to re-add the aliasing back in to make the simulate logic work, because the simulate logic uses a bunch of the aliased tags, and without the aliasing in place, those don't work. Equals to, uses some of those, and then you'll add some arrays. Yeah, I think I've covered all of them. Okay, so the last, so in the lab, it has you use a, what is that? FAL. So a file arithmetic logic. And when I saw that, so like I did up here with the average controller, let's figure out how this works. So for control, it wants a control block. So FAL control. Number of elements in the array to be manipulated, the position of any offset, how to distribute. This information applies. Performs copy arithmetic logic and function operations to data stored in an array. Okay. So this takes an array of 10 starting at position 0, mode all. New set points 0. Ten plus new FAL control dot position. Let's see what that's not. So we'll trigger it. 19. Let's see. Okay. So the instruction will take the expression that you enter into it and perform that math upon the array. That's kind of neat. Wow, that would save a lot of time. Sorry. Yeah, so that's part 4. So what you'll do is you'll have to add it in. It steps through it fairly well. For the control for these type of functions, I find that the easiest way to create that tag is throw the function in, and under control, you saw where it would be question marks, and I right click new tag. One of the things that this logic software is fairly good at is sorry, my daughter's being silly. Would be knowing when you right click, it will tell you what is valid, and it will guess what it is that you want to create in that location. So this one, because I'm the sequencer load could be a number of different items. So the source and the arrays. So the array here, the only data type that the array is allowed to be is a dint, but the source could be a dint, int, or a single integer. The length has to be a dint. So especially for the controls, you can just kind of SQL control, right click, and it will create that for you, saving you a bunch of jumping around. Yeah, I think that likely to be the biggest question from this one. So that's all I've got for you guys for tonight as for lecture. So if you guys want to get started on your lab or work on the lab later this week, if I haven't set the due date, I will for next week. And I do recommend getting it done next week. There will be a lecture, but then I will be assigning I think it's the final. Yes. So at the end of next week, after the lecture, there is a lab for next week, but I'm also going to go over and assign the final project to give you guys 2+ full weeks to work on that. So I would recommend, if you haven't submitted the first project, I would prioritize getting that done before next week. So you don't have 2 projects to finish up. And then you can work on the labs. They are worth less than the projects are. So not telling you how to use your time, but if you're pinched, I'd work on the projects. Yeah. So if anybody has any questions, I'll be here. I'm gonna go use the washroom, and I'll be back at my desk. And I'll let you know when I'm back.